Hello and greetings to everyone. We are going to continue from where we ended last time under the set of integers with the correction of the following exercises for application. Question 1 says fill the empty spaces below using this symbol which stands for belongs to, or this other symbol which stands for does not belong to. Let's proceed with the solution. We take question 1A. We have 490. We have the empty space. Then we have z minus. You know, z minus is simply a set of negative integers. Z minus, this is the set z minus. We have 3 dots indicating that the negative integers are infinite to the left hand side. -4, -3, -2, -1. We end at -1. So this is z minus. This is a set of negative whole numbers. The number 490 is a positive whole number. Therefore, 490 does not belong to the set of negative integers. We are going to make use of this symbol. It does not belong. Next, we have for B, we have the number -374. Then we have the empty space. We have z plus. You know, the set z plus is simply the set of positive whole numbers. We have 1, 2, 3, 4, 5, 6, 7. It is infinite to the right hand side. The number -374 is a negative number which does not belong to this set. So we are going to make use of the symbol does not belongs to. Next, we go to C. We have the number -1000 over 10. This will simply be equal to, if we divide 1000 by 10, first we are going to put the sign which is negative. Then if we divide 1000 by 10, it gives us 100. Then we have the empty space. Then we have z, which is the set of integers. We know z, the set of integers, is comprised of the set of natural numbers and their negative counterparts. So we have 3 dots. -3, -2, -1, 0, 1, 2, 3, and I'll end with 3 dots. So if we extend these numbers to the left, we are going to need the number -100, which belongs to the set of integers. So in this case, we are going to make use of the symbol belongs to. Next, we go now to D. We have -pi. We have z. Making use of our calculator, we are going to notice that pi gives us a value of 3 point something. It gives us a decimal number. It's not a whole number. So attaching a negative sign to that decimal number, it gives -3 point something, which is not a whole number. And such a number does not belong to the set of integers, since the set of integers is made up of the set of whole numbers, be it positive or negative. So in this case, we are going to make use of the symbol does not belong to. Next, question 2 says fill the empty spaces below by using you can see using less than or greater than. Question A, we have negative 85. We have the empty space, negative 84. Take A, we have negative 85 is empty space, negative 84. Okay, if we were to draw a number line, negative 85, this is our number line, negative 85, negative 84. Negative 85 is to the left hand side of negative 84, which means negative 85 is less than negative 84. So in this case, we are going to fill this space with the symbol less than. For B, we have 31, we have the empty space, we have the number negative 3001. In this case, we have a positive number and a negative number. When we have a positive number and a negative number, we know the positive number is always greater than the negative number. So in this case, 31 is greater than 3000, negative 3001. For C, we have the number negative 25 all over 5. This will simply be equal to, if we are to perform the necessary simplifications here, we know the sign is negative, we are going to put down the sign. If we divide 25 by 5, it gives us 5. So negative 25 divided by 5 is equal to negative 5. The empty space. For the next, we have negative 10 on 2. We know this will simply be equal to, the sign is negative, I'll put down the negative. 10 divided by 2 gives us 5. So in this case, we have a negative 25 over 5, which is equal to negative 5 on the left hand side. Then on the right hand side, we have negative 10 over 2, which is still equal to negative 5. In this case, we cannot make use of a symbol less than, because negative 5 is not less than negative 5. We cannot make use of the symbol greater than, because negative 5 cannot be greater than itself. So in this case, these two fractions, they represent the same amount. So we are going to fill the empty space with an equal to sign. Negative 5 is equal to negative 5. I know the sign was not given, but you had to reason it out. But yeah, the same. For question D, we have the fraction negative 742 all over 2. We know this will simply be the same as negative, since the sign is negative. We divide 742 by 2. 2 will go into 7 3 times, remainder 1. 2 will go into 14 7 times, 2 will go into 2 1 time. So this will give us negative 371. Then we have the empty space, then we have 0. Remember, 0 is greater than any negative number. Therefore, negative 371 will simply be less than, since it is to the left, will be less than 0. We are done with D. Next, let's go now to question 3. Question 3 says, answer true or false in each of the following. So question A, we have a set of natural numbers excluding 0, n star is a subset of a set of natural numbers. First, you know the set of natural numbers n star excluding 0 has first element 1, with 3 dots. A set of natural numbers has elements from 0, 3 dots. So you see that this set, all the elements of n star, they are elements of the set n, and the set n has 0, which is not found in the set n star. So n star is a subset of n. So here is true. Next, we go now to B. We have z minus is a subset of z plus. Remember, z minus has elements. We have 3 dots. Let's start from -4, -3, -2, -1. Hence here, z plus has elements. Start from 1, 2, 3, 4, 5. Remember, 0 is a neutral number. So in this case, comparing these two sets, here it is telling us that all the elements of z minus are found in the set z plus. Comparing the two sets, z minus has negative whole numbers, z plus has only positive whole numbers. So you will see that the elements of z minus are not found in the set of z plus. So in this case, it is false. It's not true. For C, we have z plus union z minus is equal to z. Okay, z minus has elements. We have negative whole numbers. Z plus has elements, positive whole numbers. Then we know the set z has elements, negative whole numbers and positive whole numbers, including 0. Three dots. So if we take all the elements in these two sets, we are going to have something like this. Let's take z minus union z plus. This will simply give us a set as such. And 1, 3 dots. So you see that comparing, if you take this set, you compare this set and this one, all the other whole numbers are present except 0. There is no 0 here. Therefore, the set z is not equal to the union of z minus and the union of z minus with z plus. So in this case, we are going to say it is false. Next, we go now to D, question D, which says that we take the union of the singleton 0, singleton, it is a set which has only one element with z plus equal to the set of natural numbers. We know the set of natural numbers. This is the set of natural numbers. We know this is our z plus. Z plus starts from 1. So if we take the union of the singleton 0 with z plus, this is z plus 1, 2, 3, 4, 5, 3 dots. You know, this will simply give us, taking this union, 0 will become the first element now. 1, 2, 3, 4, 5, 3 dots. And we know this set is the same as a set of natural numbers. So in this case, it is true. We are done with the correction of the exercises for application. If in case there are any questions, make sure you leave them at the comment section. Do well to like the video. Thank you.